In a layer 2 scaling world, the notion of users having a single blockchain address will disappear. Users will end up with multiple accounts on different layer 2 solutions depending on their interactions with different applications. This complex transition is driven by three factors: layer 2 scaling, smart contract wallets, and privacy needs. With layer 2 scaling, a user could have an account on Optimism if they are a member of a DAO that exists there, a ZK Sync account if they are holding a stablecoin in a system there, and even Kakarot account if they tried an application on it. Smart contract wallets complicate matters because it's hard to maintain the same address across layer 1 and different layer 2s. Most users use externally owned accounts, EOAs, but with smart contract wallets. It's tricky to keep the single address across networks. While efforts have been made to make addresses equivalent across networks, this doesn't always work perfectly due to differences in the layer 2 implementations. Privacy considerations make users have even more addresses and could change the types of addresses we use. Stealth addresses proposals mean users might have one address per transaction. Other privacy schemes, such as Tornado Cash, change how assets are stored by placing many users' funds in the same smart contract. These transitions pose significant challenges to simple actions such as paying someone. Rather than needing a 20-byte address, transactions might require more complex information. Recipients might need to provide the layer 2 alongside their address, and senders' wallets might need to route funds through a cross-layer 2 bridging system. In terms of key recovery, the default approach in a multi-address world would be to run the recovery procedure on each address separately. This process, however, has potential issues, including impractical gas costs and privacy concerns. An elegant solution could be an architecture that separates verification logic and asset holdings. Each user could have a keystore contract in one location, with the verification logic of each address pointing to the keystore contract. Spending from those addresses would then require a proof going into the keystore contract, showing the current spending public key. In summary, the future of blockchain interactions will involve users having multiple addresses across multiple layer 2 solutions, driven by scaling needs, smart contract wallets, and privacy considerations. This transition poses challenges, but also opportunities for innovative solutions in the realm of key recovery and payment execution. As Ethereum continues to evolve, we see the birth of a new chapter, the pursuit of decentralized scalability. This journey has implications far beyond the increase in transactions per second. It touches upon everything from privacy to how we interact with blockchain and, more fundamentally, how we understand our identities in the digital landscape. If you are still here, you probably enjoy our videos, so make sure to leave a like and subscribe, we really appreciate it. The pivot towards layer 2 solutions and privacy-centric models is promising, but also presents a new set of challenges. In a world where a user's identity is no longer tied to a single address, wallets need to safeguard not only the assets, but also the privacy and integrity of users' data. This new paradigm will require sophisticated solutions that manage multiple layers of encryption keys, addresses, and recovery paths, ensuring both the security of assets and privacy of data. As the notion of identity undergoes significant transformation in this decentralized context, it's clear that the concept of an address also needs to adapt. In a future where users interact across multiple layer 2 chains, privacy-preserving mechanisms, and a multitude of dApps, our identifiers need to encapsulate those complexities. The notion of ENS as the primary identity could be a first step towards simplifying this process. Yet it presents its own limitations, as it may tie too many attributes to one's name. An alternative might be to rely more on keystore contracts that are not bound by names and can provide a richer identity profile in the counterfactual friendly way. Another direction could be the evolution of user-facing addresses, adopting techniques reminiscent of the Bitcoin payment protocol. Such methods might require direct communication channels between sender and recipient, generating real-time payment information to reduce friction. However, the exact paths forward are still being paved, and a blend of different techniques might be required to deliver a seamless experience to end users. The task ahead is challenging, but it's a necessary step for Ethereum and the broad decentralized space. In conclusion, the road to a more scalable, secure, and private Ethereum is not without obstacles. But these challenges pave the way for exciting innovations. The changes brought forth by Layer 2 solutions and privacy-centric models redefine the way we interact with the blockchain and our digital identities. The focus on accessibility for regular users, along with maintaining decentralizations and understanding, will drive the continued success and growth on Ethereum.